Hello and welcome to the video on circles. By the end of this video, you should know what a circle is and identify some of the basic components of a circle. Let's start with what a circle is. A circle is really just a set of points that are the exact same distance away from a common point, which we're going to call the center. So if I have a point, I'll call it point A, and I wanted to know every other point in this plane that was 3 inches away from A. Let's say that this distance right here was 3 inches. So point B here would be 3 inches away. Line segment AB would then be 3 inches long. While B isn't the only point that is 3 inches away from A. This point right here would also be 3 inches away from point A, as would the one over here and maybe that point up there and a whole bunch of other ones. And when I combine all those points together, every single point, which is exactly the same distance away from A, I wind up with the set of points, which are all exactly 3 inches away from A, which gives me a circle. That circle we would call circle A, because circles are always named by their center points. If I had some other circle, we'll call it circle X, I would know that the center of that circle would be point X. Let's take a look at this circle. So this circle would be called circle X. There are some other line segments here on this circle, and we're going to learn the names of these parts. The first one you probably have heard before is called a radius. A radius is a line segment with one of its endpoints on the circle itself and one of them at the center of the circle. We have a couple examples in this picture. An example would be line segment XB. One of the endpoints of XB is on the circle itself, it's point B. The other endpoint is on the center of the circle, that is point X. So XB would be the radius of this circle. There are some other radii here as well. The word radii is just the plural of radius. XC is also a radius, and AX is also a radius. I can write those just like I would any other line segment. So AX, XC, and XB are all radii. And again, radii is the plural of radius. Another term that we're going to use is a chord. A chord is a segment that has both of its endpoints on the circle itself. There are actually two chords in this particular picture. Chord AD has both of its endpoints, point A and point D, on circle X. And there's a second one here as well. Segment AC also has both of its endpoints on the circle itself. It is also a chord. So those are our two examples of chords, AC and AD. A third name of a segment inside of a circle is a diameter. A diameter is a chord. It's just a special type of chord. A chord has both of its endpoints on the circle, so a diameter has to have that as well. However, a diameter can't be just any old chord. It has to also pass through the center of the circle. So in this case, our only diameter is AC. It has both of its endpoints on the circle, and point X, or the center of this circle, is also in the middle of segment AC. Some things to note with the lengths of diameters and radii. If you remember, there were three radii here, XB, XC, and XA. Because the diameter AC is made out of two radii, there's a relationship there. The length of any diameter, so the length from A to C, is just equal to 2 times the length of any radius. So if our radius here was 7 inches long, because AX is 7 inches, that XC would also have to be 7 inches. So the length of our diameter would have to be twice that, or 14 inches. So the length of any diameter would always be equal to 2 times the measure of a radius, or in other words, the measure of a radius would equal half the measure of the diameter. Concentric circles are just coplanar circles that have the same center. An example here, I've drawn 2 circles. Both these circles happen to have a center of point A. When you're naming these concentric circles, we would just name them circle A. But to differentiate them, we talk about their radii. This one might be circle A with a radius of 3 inches. The other one here might be circle A with a radius of 5 inches. You could also name them with their endpoints. So the smaller circle here would be circle A with a radius of AB, or the larger circle, circle A with a radius of AC. Two other terms that we need to know here, we're going to see the words inscribed and circumscribed a fair amount. Inscribed means that it is inside of, if I had to make a generalization. Essentially, in this particular picture here, this polygon, FGHI, is inscribed inside of circle J. So because each of its vertices of that polygon are on the circle itself, it would be called inscribed. Circumscribed would be talking about the circle. So this circle, circle J, is circumscribed around polygon FGHI. So when I'm talking about the polygon inside, in this case, I would say the polygon is inscribed inside the circle. If I was talking about the circle, I would say the circle is circumscribed around the polygon. Let's try a few examples here. Example number 1, name the circle. We learned earlier circles are named by the centers, so this is circle X. Part B, name the radius of the circle. Well, we have 3 to choose from here. We have segment AX, segment XE, or segment XD. Part B, name a chord of the circle. Remember, a chord has both its endpoints on the circle, so I could talk about segment AD or segment BC. I'll just use BC here. And D, name a diameter of the circle. Well, a diameter is a chord, but it has to go through the center. So this, in our case, is the one going right through here. That is diameter AD. Problem number 2, circle Q has diameters of RT and WS. We want to answer the following questions. We're told that WS is 18. Well, if WS, that's my diameter here, is 18, then both of these radii here would be 9. So what is WQ? Well, it would have to be 9. Problem B, if QT is 24, find RT. Well, if QT is 24, it's a radius. So RT, the entire diameter length, would have to be twice that much, because this radius here would also be 24. My diameter would be 48. And C, if QV is 2, how long would XQ be? Well, XQ is another radius. It would also be 2 units. And problem number 3, if we're told the diameters are 10 inches for circle B, that means this length right here would be 10 inches. Well, if the diameter is 10 inches, I know both of the radii here would be 5 inches. For circle D, I know the diameter is 20 inches. If this diameter here is 20 inches, that means the radii would be 10. So from B to D would be 10, and from D to F would also be 10. And circle F has a diameter of 14 inches. If its diameter is 14 inches, I would know both of its radii would be half of that. So EF here would be 7, and FG would also be 7. So the question here, find CD. Well, if I know B to C is 5 units, and B to D is 10 units, then this other piece over here, using the segment addition postulate, would have to be another 5 units. So CD here would be 5. Similar logic for problem number 2. If DE is what I'm looking for, well, since I know that DF is 10 units, that's this entire length here. Here, let me make this easier and get rid of some of this other information. If DF is 10 units and EF is 7 units, then the leftover part right here, DE, would have to be 3 units, using the segment addition postulate.